right. Well, thank you everyone for having me. I'm quite excited to give this talk. Today I'm going to be talking about cloud native analytics infrastructure. And what I really want to do is I want to give you an overview of all the options and tools that are out there and kind of drill it down to what do you actually need? What are the decisions you should make when thinking about, hey, I need to analyze data. I need to collect data. I need to look at data. I want to run reports. What is it that you actually need to collect, process, and then visualize maybe later on? Data from your applications, from your users, really from a wide case of background and range of use cases. But first, so hi, I'm Chris. I work for Do It International, a large cloud and Google Cloud partner. I'm a cloud architect there, and you can reach me at chris@doitintl.com. But without further ado, let's jump right in. So the moment you start thinking about data analytics in the Google Cloud, you might be going to this page, the product overview page of Google Cloud, and see what are they having there. Well, they have a bunch of products, and this is just the highlights, right? This is just a top line. You can drill down into each of these and see sub-products and sub-features and a whole, like an endless catalog of stuff that helps you to do something with data. What we want to do, we want to break it down to 3 simple layers that you should think about. And then for each, I'm going to help you make a decision what you actually need in this layer. So let's take a look at the layers that we're talking about. We're going to be talking about database. That's kind of the central thing for all things data analytics, right? You need a place where you can load data into and you can use to get data out again. Then processing. We're going to see that there are a couple of options for processing and a couple of use cases that kind of drive these processing demands. And then lastly, scheduling, because you don't want to put a Post-it note on your screen, hey, remember to calculate this report Monday morning. You want to have something automated that does all these steps that are maybe required to prepare data for analytics and run these in an automated fashion, in a workflow, on a schedule, whatever might suit your use case. And we're going to look at a couple of options there. So let's jump right in. Database. When we're talking about databases, the first thing I have to say, analytics will require an SQL database. Even though there are a lot of tools that you can put on top of the SQL database to you not having to write SQL to analyze data, the language, the universal language for pulling data, working with data, etc., is still SQL. So when we're picking a database, it's really going to be an SQL database. And now, again, we have plenty of options, right? There are like the very well-known and more transactional databases like a PostgreSQL or MySQL. These are databases that are focused for application use cases. If you're coming from an application background, you might be very familiar with these kinds of databases. And to be honest, they're really good at data analytics. They have a lot of positive things that they can do really well. But they also have some limitations, especially when we're talking about getting bigger and having a database that is not just on one server, but maybe can handle a lot of data on a lot of servers. And to shortcut this conversation a little bit, if you are on the Google Cloud and you need a place to put analytics data and to do analytics, it is most likely going to be BigQuery. This is one of Google's earliest products in the Google Cloud. And it has a couple of things that make it really the database for analytics, not just in the Google Cloud, but probably across all the clouds. So let's look at what this is. The first thing is serverless. We just had a really nice talk about serverless. And there are a lot of benefits of using serverless services. With BigQuery and data analytics, this primarily means zero maintenance. You don't have to worry about provisioning compute, about updating servers, patching servers, scaling up more resources, scaling down resources. All of this stuff is managed by Google for you. It's really, especially when you're starting small, the place to be, because you don't want to have another DevOps setup just for running analytics, right? The second piece is standard SQL. A lot of databases have their own fancy kind of syntax for SQL. And this can make it less portable. There are slight differences in the flavor, how specific commands are run, how strings are concatenated, and all that kind of stuff. BigQuery is using the ANSI standard SQL, so like a standardized format of SQL that works across most databases and will be a safe standard going forward. But still, this vanilla SQL has plenty of power, as we're going to see going forward. BigQuery really is a full power workhorse for all kinds of analytics use cases. In fact, and that's the next point, it can scale to petabytes if you need it to. But you might be saying, well, I don't have petabytes. It doesn't really matter. It works just as well for megabytes as well. That's the beauty of BigQuery. It's serverless, right? It scales from nothing to a real lot in seconds, and you don't have to worry about how it does it. You just have to bring your data and get going. It has a powerful API. While a lot of more traditional databases require you to manage connections, create a connection, and then send SQL strings over that connection, committing them in transactions, etc. With BigQuery, you can do a lot of these operations via an API. Again, if you're coming from an application background, this is a really familiar way of working with services, right? Using a REST or an RPC API. And of course, you have a really nice UI, but you also have a really powerful CLI. So BigQuery kind of works very much like a cloud service and less of an instance-based database. And lastly, BigQuery is cheap. You really only pay for what you use. And that means, for example, if you store data, the moment you start, like the second to be precise, the second you start storing data in BigQuery, you will be charged for the storage. The storage pricing is actually compatible with the cheapest storage you can get on the cloud. For example, Google Cloud Storage or S3, right? Really compatible long-term storage pricing is available in BigQuery. And then when you actually run a query to look at the data, you also only pay for the query when it's running, like the amount of data that's pulled into the query. The moment the query stops, the query engine that Google has ready in BigQuery is not charged to you at all anymore. So these pros together kind of give you a database or an analytics solution that scales not linearly with your data, so with your usage, with your business success. It kind of just, I don't want to say linear, but it's scale much slower, the overhead that you have when running this. So BigQuery, I'm sorry that I can't give you like a wide list of options here, but it wouldn't be fair. BigQuery is the place to go when you start with analytics, and probably also the place where you want to stay long-term when you get a lot of data and have a very heavy lifting, heavy use cases running in your analytical database. There's another really nice thing about BigQuery. There's a couple of ways in how you can get data into the database. The first one is you can load batches of data from files into BigQuery tables for free. And that is, I mean, that's not a big thing when you're just loading small CSVs, right? But when you start loading huge amounts of data, I'm talking terabytes of data, you are never going to be charged for the load operation itself. This is all on Google. Even if it's a heavy load and you have to uncompress large amounts of files, not just one, but many files, Google will not charge you for this. This is always going to be free. And by the way, it's also free to get data out again. The export jobs are just as free. The other way to get data in is to write individual records directly into BigQuery tables via REST RPC calls. Again, traditional databases would require you to open a connection, have an insert statement like in SQL string, that kind of where you have the data in and then write it this way. With BigQuery, you can do a REST or an RPC call right into a table. Extremely powerful. This is something that's extremely easy to implement in an application, just like writing a log, basically. There are, additionally, as a third option, there are a couple of fully managed BigQuery transfer services for common data sources. So for example, there's a predefined service to load files from Google Cloud Storage on a schedule. There's also a service to load data from the Google Play Store, for example, the reporting API right into your BigQuery. It's just the same for YouTube, Google Ads, and a couple of other sources. And then lastly, this is kind of a hack, a trick. I might not want to rely on this for large-scale applications, but if you want to get going quickly, you can actually stream application logs right into BigQuery. So if you're having a service running on Google Cloud and you're writing something to stand it out, it's going to go into the into the general Google Cloud logs, formerly known as Stackdriver logs. And from there, you can create a filter. Oh, just these kind of logs I want to have streamed into a table in BigQuery. This is extremely powerful and can make it super easy because you might already have logs for typical activities that are happening in your application. Getting these into an analytical database like this is super easy and super straightforward. So a couple more reasons why you might want to think about BigQuery from the very beginning. Next, let's look at processing. We have a database. Now we want to do something with data. And there are really two scenarios when you have to think about processing. The first one is you have data that does not fit into your database right away. That is one scenario where you typically think of, you have a CSV that's mail formed and you have to kind of change it before you can actually load it. Or you have some weird JSON data that doesn't fit like that into a BigQuery table. BigQuery is quite flexible of what it can load, but there are limits to it. And then you need some processing. Also, you might want to run processing within your database. You have data already in the database, and now you want to transform it, you want to aggregate it, you want to run some machine learning on it, you want to run some advanced, like kind of transform data that's in there that kind of has a weird format. You want to extract data out of string fields and that kind of stuff. That's also another use case. Let's look at the kind of tooling you could do for that. The first one, and that's it's kind of an obvious one, SQL. It has a lot of benefits of running as much as possible in SQL because it runs in the database, it scales, and it's optimized for this kind of stuff as well already. You can use any kind of generic compute. Obviously, you can load data either from the database or from outside the database and then back into the database from kind of as simple as a cloud function, as we just learned, to something as complicated as a Kubernetes workload, or even something on-prem. It doesn't really matter there. This is also an option for doing some processing. And lastly, data flow, kind of the gold standard for data processing in the Google Cloud. It is super powerful, extremely scalable, and extremely flexible at the same time. Let's dive into these three a little more and see when to use what and when not to use something. Let's start with structured query language, SQL. Again, it's powerful, scalable, and optimized, and is optimized for the processing environment that you're already in. It's in your database. Your database is meant for this. Very often, I see, especially application developers, they are maybe not too familiar with the analytical functionalities of SQL. And they see a problem that goes a little bit beyond a sum or an average or something like that. And they immediately jump, okay, let's get data out. Let's write a little script. Let's write some Python. Let's write something more advanced and run it in a container. And people think twice if you really have to do this. SQL is extremely powerful. And it has a huge benefit of kind of staying in the language or in the ecosystem that you're already using, a database, for these kinds of processing. SQL has amazing features, like, of course, all the kinds of aggregations, statistical calculations, window function, all this kind of awesomeness. But it can also do geographical functions. Like BigQuery, for example, has a whole suite of data functions to calculate distances between geopoints or calculate the size of areas, check if areas overlap, and all that kind of stuff. There's functions dedicated for networking usage, right? You have a full URL and you want to extract the host name, you want to extract the port, the protocol. There are pre-built functions to do that in just a single line, really straightforward. And then there are other SQL standards that I didn't list here, but for example, in BigQuery, you can run ML use cases in SQL in the database. Extremely powerful. So really think about SQL a little more when you're thinking about processing data. So do use it as long as you can, really. And you should use it, try to use it as much as possible because you have it available in your stack already the moment you're starting using a database. Don't use it. Well, that's what I mentioned earlier, when your data needs transformation before loading it to the database. So if you have a file that cannot be loaded to a database, obviously you can't run SQL on it. So in these scenarios, you will need something else. And obviously, also, if you're trying to do some extremely fancy, that SQL is just not meant for, right? There are scenarios where SQL is kind of overpowered and not the right tool, and you need something that's a little more flexible that can do other stuff, like super fancy machine learning with super detailed configurations, for example, or anything that doesn't kind of fit in the kind of table way of thinking that SQL has. So structured query language, like, should be your first go-to for all kinds of processing need in data analytics. The second thing I mentioned, generic compute. This can be anything from a cloud function, cloud run, like we just heard, Kubernetes, Google App Engine, or just any VM. You have full control and flexibility of how you do stuff in there. You can bring your own language, you can bring your own kind of compute power, you can bring your specialized hardware like GPUs, but you have to implement scaling and optimization yourself. Like, you might be thinking, well, a cloud function, I can invoke a lot of cloud functions at the same time. Yes, but typically when you load data, for example, from a file, you can't kind of break it. You're going to have a hard time breaking up that file in generic compute. You always need to load a whole file and then process on that file and then maybe load the results into a database. But what if your file size grows because your business grows, your user base grows? All of a sudden you have much more transactions, and the daily transaction CSV all of a sudden get huge, or it's not just one CSV anymore, but multiple ones. It's going to get more and more difficult running these on generic compute resources. So do use it for simple and small tasks and for orchestration tasks. When you don't only basically tell an API, hey, service X, here's my file in service B, please load that file. That's where generic compute can be really helpful and useful. But the moment where you load the data and do something on it, start to get careful. Don't use it for intensive processing, for large amounts of data, and when you want to avoid technical debt. Honestly, I've seen that a lot, where all of a sudden your generic compute solution for a data problem kind of became technical debt because you've been using it too long and the data grew and you kind of started gluing hot fixes on it and never really got to a stable solution. And then lastly, again, a little bit of the gold standard, the biggest solution that Google has to offer for powerful and scalable data pipelines, Cloud Data Flow. It's a managed service, so it's not entirely serverless. Google will manage instances in the background for you, and you actually have quite a bit of control over these instances, for example, networking control, but also the kinds of instances that are running in this service. But Google will make sure to run like the latest service software on this. They will take care of scaling machines up when your workload increases. They will scale it down, of course, as well, etc. So it is inherently a managed service. Cloud Data Flow is actually just a runner for an open source framework called Apache Beam. So when you write a pipeline in Cloud Data Flow, you write it with the SDK of Apache Beam. And when you say, okay, my pipeline is ready, please run it now, you submit it to Cloud Data Flow. If you ever decide, actually, you know what, I don't want to use Cloud Data Flow anymore, or I have this specific workflow that for some regulations reasons, I have to run this on-prem, I can't bring this to the cloud, you can also have other runners, like for example, Apache Flink or Apache Spark, and run those wherever you like with the same code written in Apache Beam. Writing code for Apache Beam, there are 3 SDKs available at the moment: Java, Python, and Go. It is a little bit like with Spark though. It's inherently written in Java. So the most straightforward development experience you will always have in Java. But I have had great success with Python as well personally. In general though, if you have the option to go with Java, I would still probably recommend going with Java. So when to use this? Do use it for heavy processing and large amounts of data. Do not use it for quick one-off solutions. Honestly, it's not going to make sense. Data flow and Apache Beam especially is a big system. It has a lot of concepts that you have to think about, that you have to learn. The way data flows through such a pipeline, it's a little special. You have to have a couple of specialists, or at least a little bit of time to understand the specialities of Apache Beam before you really are effective in it. But once you are effective, it is really the ultimate workhorse for all kinds of data analytics in the Google Cloud. So there we are, 3 options for processing data: structured query language, generic compute, or Cloud Data Flow. Let's take a look at the next piece: scheduling. We have seen the database and BigQuery itself has some options for loading data right away, but we've also seen that processing has a lot of the scenarios where you want to process data. And typically that you develop that once and then you want to run it regularly. Think of, for example, the CSV that I mentioned earlier. Your application writes a CSV on a schedule on a regular basis, and that CSV is written to Google Cloud Storage. Now, from Google Cloud Storage, you want to load it into BigQuery. That's one action. You have to know somehow, okay, this has to happen at a certain period. You could tell your application to, after it's written a CSV, to also load into BigQuery. Well, that's kind of I would personally rather prefer decoupling this. Also, you might have multiple backends creating these, right? Which backend is then the one calling the shots on importing? And then also the kind of, for example, queries running on top of it, or the heavy lifting processing that you want to do with data flow on top of it. Who's scheduling this? Who's making sure that this runs automatically? This is what you need a dedicated service for. And again, with these services, you have three options that I would recommend when you're getting started. The first one is Cloud Scheduler. Cloud simply trigger HTTP requests or pops up messages. That simple, really can't do much wrong, can't make much errors here. It's really straightforward. We're gonna take a look in a second. BigQuery schedule jobs. Another nice feature of BigQuery, you can schedule a lot of kind of function stuff that you typically do with BigQuery from within BigQuery. Basically, BigQuery has a little scheduler built in. So you can automate queries or import jobs from within BigQuery. And lastly, CloudComposer, another kind of like the gold standard tool for data analytics at the moment. Powerful and flexible workflow orchestration is what CloudComposer gets you. We'll take a look at all these three in a little more detail. The first one, Cloud Scheduler. It's a lightweight and simple approach to trigger. You can trigger HTTP requests with any valid HTTP method. You can insert pop-up messages into pop-up topics. And you can trigger paths on Google App Engine services. So if you have these kind of admin routes on your application, this is Cloud Scheduler can trigger these as well. There's a couple of nice things about Cloud Scheduler that add on top. So of course you can say you have a kind of a timing. You can use it cron syntax, for example, to define your schedule. But you also have other approaches of like more verbal approach. You can actually say every Monday, for example, if you don't feel too confident with the cron syntax, you can write every Monday at 8 and Cloud Schedule will understand that. But you can also dynamically attach auth headers to your requests. So you define a service account that the Cloud Scheduler uses when it triggers the HTTP request. And this allows you to, for example, talk to resources, serverless resources that are not public to the internet, right? For example, for Cloud Functions or Cloud Run, you now have a method like an IAM method to allow who can invoke this resource. And by attaching an auth header, this Cloud Scheduler can invoke this IAM secured resource. And also, you can trigger Google APIs. All right, all the Google APIs, you might be usually using a client library for this, but at the end of the day, it's a normal REST API or RPC API, right? With Cloud Scheduler, you can make HTTP requests directly to Google APIs with auth headers attached, for example, to start resources or delete resources every morning and every evening. But you can also use this in a data analytics fashion to run queries. So when to use it? Do use this to trigger individual compute resources. And that's really the key to this kind of a scheduler. When you have an individual task, but do not have a complicated workflow that runs, then Cloud Scheduler is a really good option. If you have something like load data, transform data, run report, 3 steps, Cloud Scheduler, I mean, you can make it work. You load it, then 10 minutes later, you have the next one, and 10 minutes later, you have the next one. You step in your workflow. But there's no dependency between these 3, right? So if the first one fails, the second and third one is still going to try to execute. And also, there's no retrying logic or something like that on Cloud Scheduler. So don't use this for multi-step workflows, or also don't use this when jobs are changing regularly. This is a really that simple service. There's no version control on top of this. There's nothing that you can really check into Git to know what's happening if you're working on this with a team and everyone's working on that on different features at the same time. There's no way to merge stuff together, etc. It's really a straight, very thin layer, a very thin service. So when jobs are changing regularly, you might consider one of the other options I'm going to be showing you. The next option is BigQuery schedule jobs. I mentioned that already, right? You can run SQL queries or transfer jobs directly from within BigQuery on a schedule. This is actually pretty powerful because it already has dynamic parameters in queries to run, for example, controlled backfills and reruns. What do I mean by that? Well, think of a SQL statement, right? You have to select something from something where date equals today. So you're running this query just for today's data. Now you notice that last Tuesday, the original data was not complete, so you had to reload that original data, and now you want to rerun the query. If you are just put it today in the where statement, it's not going to work. With BigQuery scheduled queries, you can put like a Jinja template, basically, in the SQL, And when BigQuery is executing the job, it's going to automatically place the correct date of that run in the SQL string. Really, really powerful. You can do similar things with files with these data transfer services. So for example, load files from Google Cloud Storage, from typical reporting APIs, or even S3. That's a pre-built feature for that, to run that on a schedule every Monday, every day, every hour, every minute. So do use this to automate individual BigQuery tasks. Because individual, we have the same limitations that we've just seen previously. It's going to be, there's no workflow orchestration, no multiple task kind of thing. So don't use this for multi-step workflows. And also don't use this when jobs are changing regularly. Honestly, it's the same thing again. There's no version control on the queries that you're executing in scheduled queries. There's no version control on the kind of settings you're having. So be careful if you're having complex workflows that are changed, where a lot of teams working on this, or a lot of individuals are working on this. Maybe start thinking about a more stable solution, which is CloudComposer. CloudComposer is, again, a managed service for an open source framework called Apache Airflow. And this really is, again, I'm overusing the word gold standard a little bit, but I've seen so many organizations, data organizations, picking this up in the last couple of years. It's the tool for complex workflow orchestration. It runs on top of a Kubernetes cluster, so we have really controlled compute resources underneath. And you, in general, therefore also have full control of the network configuration. Composer allows you to structure complex DAGs, directed acyclic graphs of workflows. So you can start with a simple task, then fan out to a lot of tasks that should run in parallel, and then reduce again to one last job that kind of checks or sends out an email, sends out a final report, something like that. You can go crazy with these kinds of DAGs, fan out, reduce, fan out, multiple pieces in parallel. That's all can work really well. So when to use this? Do use it for complex workflows and tasks. For multi-cloud workflows. If you're having to load data from another cloud platform or from on-prem into Google Cloud, or have to load from Google Cloud to somewhere else, then this is a tool that gives you the right flexibility. And also, we've seen this also in the serverless tasks previously, if you have special networking requirements. If you do need that static IP, you can get it with CloudComposer. If you do need to be on that internal network, you can do that with CloudComposer. And when not to use it, don't use it for quick one-off solutions, and don't use it without taking the time to understand its specialities. Just like Dataflow, CloudComposer is an advanced data engineering tool. It is really powerful, but you have to take some time to figure out why it's doing certain things the way it's doing it. It's not UI-driven, it's deeply code-based, which is the amazing things for an engineer, right? You don't have to do clicky something in the UI. It is a code-based service. But obviously, you have to learn a library. You have to learn the execution mode of this service. And, well, you need some time to figure out how to configure your service correctly, or your workflows correctly, sorry. So to sum it all up, we've talked about databases, processing, and scheduling. And I gave you a couple of options and examples of tools that you can use for these three areas. So database, honestly, again, sorry for not having more options, but if you're on the Google Cloud, take a look at BigQuery. Processing, stay as long as you can in SQL, and then maybe use a little bit of generic compute short term if it's really necessary, but be very careful with the kind of scaling limitations that you have in these kinds of environments. And then if you really need more, if your organization is growing, you maybe have some more engineers that can take some of their time to focus on data engineering tasks, start taking a look at Dataflow. And for scheduling, start off with something easy as Cloud Scheduler or BigQuery schedule jobs. Really simple to get started, has a lot of kind of pre-built feature set, large pre-built feature set for you. And then again, when your organization matures and your data needs grow, take a look at CloudComposer and the gold standard for workflow orchestration. Thank you very much for your time. If you have any questions after this, I think that we're going to ask some questions now, answer some questions now as well. But you can always reach me at chris@doitintl.com. Thank you very much.